All right, so the last of the videos we're going to have here is when we want to do compositions with our calculator. So we're going to go ahead and we're going to enter in the f of x function for y1, and I'm going to put g of x in for y2. So if I just kind of use some substitution here, I'm actually rewriting this problem as a y2 of a y1 of a -1. Now notice I left the parentheses exactly where the problem had the parentheses. So there was a parenthesis here, I kept my parentheses here, I kept the parentheses, and then so on with the one at the end. So now let's look at how our calculator will help us do this. So I'm going to go ahead and in my y1, I'm going to put in an x squared plus 3x. And in my y2, I'm going to put in a 2x squared. Now, from here, I want to come out to my home screen. And remember in the last video, we talked briefly about all of these helpful things that are up here. So when you go alpha y equals, you have the fraction button. When you do alpha window, you have the absolute value, the log base, and your sigma notation here. If I go over to this last one, here are my vars, which makes it so nice. So if we look, I need to do y2 of y1. So I'm going to arrow down for y2. I'm going to put parentheses, alpha, trace. Now I need y1, and I'm going to put the parenthesis of -1 and hit enter. And that is your answer for what g of f of -1 is a positive 8. All right, now a little bit more complicated, but I think still worth saying to help you out. If I need to do g of f of x, well, we know that that means we're going to take this function f and plug it into g. So I'm going to do a 2 times of 4x to the 4th minus 15 plus 11. All right, now when I distribute that in, I'm going to get an 8x to the 4th minus 30 plus an 11. So I actually have this answer down here. All right, now let's see how our calculator would have helped us do that. So we're going to go back to y equals, and I'm going to enter in a 4x to the 4th power minus 15. And I'm going to enter in a 2x plus 11. All right, so if I want to see which one is the correct answer, we could go back and use the strategy we talked about with storing values. So you probably want to make a note to yourself on this and say that this is my y1 and this is my y2. And so if I go back to my calculator, let's see what happens if I plug in a 10. So for g of f of 10, all right, so if I go ahead and type in vars, so I'm going to do alpha calc, and we need to do the g first, which is y2. And then we need to do our y1. And again, remember we talked about storing, how you just kind of pick a random value? Let's pick 10. And I hit enter. And I get this number. Well, we think the right answer for the composition is this. So let's see what happens if I plug in an 8 with a 10 of to the 4th power minus 19. Notice we get the same thing. Now I could have done this with that idea of storing again, right? So I could have said 10 store for x, and then I could have typed in a y2 with a y1, but then you would keep an x here, right? That's what storing does for you. It makes that a little bit easier. And then if I look at what I know my answer is, and this is the one that worked, then I could have put in an x here. All right. And then you see that it also works. All right. Now, if I had plugged in, let's just try it out. I'm going to try option B just because. If I type in an 8x to the 5th minus 165, it's definitely not going to equal the same thing because it's not the right answer. All right. So that's kind of a different way to let your calculator help you with compositions. The other thing I just want to go over with you quickly are these infinite series. All right. So remember, we have a sigma notation for these. But an infinite series means that you have to put an infinity up here. Now, this is a geometric series, so when we write the rule, we say a sub 1 times the r value. All right, so n equals 1, a sub 1 times the r value, which in this case is a negative 6 divided by 9, right? A2 divided by A1. And then you would say n minus 1. Now, you have, let's go and find that sigma button. Alpha, window, your second one is sigma. X, right? First term. And this is where we're stuck. There's not an infinity button on your calculator. So remember, I like to do 100. Let's put a 100 in here. And then you type in your r value. And then you type in your x minus 1, and it's going to spit out your infinite sum for you. All right, so I just dragged. Okay, so you guys saw it would have been a 5.4. If we go ahead and we hit math, enter, enter there, we get a 27/5. So that's another little shortcut you can use. There is a formula for it on your formula sheet, but when we don't have, or when we have the infinity up here, you just have to plug in a 100. Now don't forget, if one of these had said no sum, then this is when we would plug in this and plug in another number too. So this one kind of took a long time. But if we go ahead, I'm going to arrow over and I'm going to change this 100 to a 50 and just make sure that they're getting close to one another, right? If the number keeps growing really big, then it means it would have no sum, right? But since we know, right, and if we look, we had a 5.39 and a 5.4. So those are definitely very close to one another, which is why we know that this is the sum. All right, so that's how you do your infinite sums on your calculator using your sigma notation. And then also just the last thing I want to look at here is when you have to do anything normally distributed, don't forget that you have the second distribute, and we're going to use normal CDF, and it should bring us to, whoops, I'm in the wrong place here. So second distribute, normal CDF, and then you plug in your values. All right. So since this one is asking us normally distributed, all right, with a mean of 0, and the standard deviation is a 0.5, and we're looking for between a 1 and a -1. So that's actually within 2 standard deviations. So maybe you guys remember between 2 standard deviations is a 95, but we don't want to have to remember. So we can use our normal CDF and say from -1 to +1, the mean we were told was 0, and the standard deviation was a 0.5, and we hit enter, and there's your 95. All right, and that is our calculator tips.